All right, the next kind of logic statement that we get with combining our phrases is when we use the words if and then. So we could say that an implication is when we join P and Q by saying if P, then Q. So here, P is the antecedent. It comes first, so ant means first. Q is the consequent. It follows. So if P is true, then Q should be true. So true, true will make this true. But if P is true and then Q is false, then this sentence must be false. Now, Q being true depends on P being true, but if P is false, then Q could be anything. So if P is false, Q could be true. That's true. We don't have enough information to know whether or not Q has been affected. So again, if P is false, Q could also be false. That could be true because, again, we don't have enough information to state otherwise. So here's my truth table for implication. Let's look at an example of this. So an example could be that my P statement is that X is a multiple of 9. My Q statement is Q is divisible by 3. So then my implication is if X is a multiple of 9, then Q is divisible by 3. So let's look at a statement for this. So let's pick a multiple of 9. So let's say that X is 27. Well, if X is 27, it is definitely divisible by 3 because any number that's multiplied by 9, so let's actually even go more basic. So X is some multiple of 9, so it's 9 times some number. Well, 9 times some number is always going to be divisible by 3 because the 3 will always go into 9. So that's going to always equal 3m. So if P is true, that it is a multiple of 9, then it will definitely be divisible by 3. So that's always going to be true. So now, if P is a multiple of 9, there's no possibility that I can think of to make a Q that would not be divisible by 3. So this combination happening is impossible, so it has to be false. But now, if P is not a multiple of 9, it is still possible to pick a number divisible by 3. So for example, my P statement, the X could be equal to 15. So this is a not P example because that would make P is false. So an example of not P would be 15. But I can see that 15 can be divided by 3. That can still be true. So my if P is false, then Q is true, that's a true possibility. But I could also think of another example. For example, I could have said not P has an X of 14. So this is not a multiple of 9. It's also not divisible by 3. That does not equal a rational number. So it's not, that does not equal an integer. It's a rational number, but it's not an integer. So it's not divisible by 3. So both of those things being false, if not P happens, then Q can also be false. That's also a true statement. So again, my implication, both are true, or the first one is false, leads to a true implication.